Most of us don't even think about air. It's clear, it's all around us, we need it to survive, and unless you're exercising and breathing hard, you pretty much take air for granted. But air is also personal, because depending where you are, air quality varies from place to place. Air is cleaner in some areas, it's more polluted in others.
While the vast majority of time air is clear, we see it being clear, but in reality air always has substantive matters into it. There are vapors and there are particles or aerosols that we're interested in. And in fact at EPA, certain numbers of those pollutants we actually measure as part of our air quality monitoring throughout states and communities.
And that personal quality of air is what drives the folks in the Air Quality Assessment Division of the U.S. Environmental Protection Agency. It runs the nation's air monitoring program out of its labs in Research Triangle Park.
And, good science brings good policy. So we really enjoy working with the science, and monitoring is a key piece of that science, obviously.
There are 4,500 air quality monitoring stations like these around the country that test the air. The stations are owned and operated by state and local governments. They are funded by the EPA, and the research is guided from RTP.
What we do is we provide the general direction on how to do that modeling. We provide the methods that they should be using, the federal methods that should be used, and kind of the overview for the national program. So in some ways we run the national monitoring program, but we don't actually do on-site monitoring.
The stations are packed with instruments measuring ozone and other pollutants covered under the Clean Air Act. The data is analyzed and used to issue air quality warnings and make regulatory decisions.
This is a monitor that actually measures coarse particles and fine particles. Coarse particles we call PM10, fine particles we call PM2.5. The important part of that is that they're very, very small particles that either lodge in your lungs or actually go through your lungs.
We're required to evaluate the air quality standards every 5 years. Well, that's because new studies come out, and new studies show the different impacts of health, of air quality on health. And so one of the things is sometimes I think our job never ends because, science never ends. And we learn new things, and we always evaluate the standards on an ongoing basis.
And that's why EPA researchers are focusing on emerging technologies.
Technologies that might be able to provide us with the ability to collect data cheaper, or more of it, or in more locations.
The items in this lab don't meet regulatory standards, but the EPA is evaluating the devices to make sure they are precise enough to allow individuals, schools, or community groups to monitor the air around them. This device tests for chemicals in the air.
We're constantly being exposed to volatile organic compounds that come off of our clothes. They come off of gaseous products when we go there and drive. They're in our house constantly because of consumer products. And in fact, just when we go there and this is just a magic marker.
It's the gas coming off.
It's the gas coming off. And so this is a fairly inexpensive device. And so if I'm a consumer and I want to go there and understand, am I potentially being exposed to volatile organic compounds? A device like this has no regulatory quality at all, but it could provide an understanding of, am I being exposed to more or less of a given product?
The EPA is also studying how the devices could fit into larger research programs.
This is a device that's fairly inexpensive, and it's measuring the particles that are in the air. It's actually counting the particles every second.
So wait, so these numbers here are the particles?
Are the particles that are being
that we're breathing right now.
That we're breathing right now. But just a simple aerosol, and this right here is just a cleaner, and you can see we get advancing indications.
But wouldn't it, if I'm cleaning, wouldn't it?
It would generate
decrease?
air. No, it would actually increase.
Because you're blowing more things into
There's more particles in the air.
However, data is useless if it can't be shared and studied. This is the next generation of EPA's Citizen Air Monitoring Program. It's called ReadyGo. That's short for Real-Time Geospatial Data Viewer. It allows citizens to upload air quality data they've collected and then examine and analyze the findings.
You like exercising outside, you want to make sure that your air quality is safe, and you can explore your region, and if you live near a highway and your route gets close to the highway, you will probably notice that in that region the air quality is worse. But as you move further away from the highway, more into the park perhaps, you'll notice the air quality is cleaner, and you might say, okay, we're going to have an outing with my family. Let's go to the park and let's not, do the trail that's near the highway.
We see that there's a wide range of technical approaches. Certainly the air quality measurements that we take for regulatory purposes has to be of the highest standard, and those are promulgated by law, and there's only specific mechanisms and instrumentation and parameters that have to be applied to collect that data. But for myself as a citizen, if I want to collect data, what are the options that I might do? And we're interested in that because if we can collect more data in a cheaper, faster, and find more ways to apply it, then that's of value to ultimately the American public.